Now let's discuss the difference between x equals a plus b all over 2 and y equals a plus b minus a slash 2. These two expressions are mathematically the same, but computationally they are not. So one may ask, what is the difference? Well, it turns out there is a difference. To illustrate this differences, we are going to use 4 different programming platforms. 1. MATLAB. 2. Python via Google Colab. 3. Excel. 4. C#. The reason I have chosen to use these languages in this order is due to some adjustments they have made to their numbers and, in the case of C#, how the compiler interprets the instructions passed to it. Well, for most part, they are the same, but for some specific combination of A and B, they are not. Part 1, MATLAB. To explain this, we will use MATLAB. Numbers by defaults are doubles, so the maximum number you can represent as a MATLAB double, which is based on IEEE 754 standard, is 1.797 times 10 raised to power 308, as can be seen in this Microsoft documentation. So let's say our A and B are big enough so that each of them is representable, but their sum is not. So let's set A equals 1.7 times 10 raised to power 308 and B equals 1.5 times 10 raised to power 308. This numbers can be represented, but their sum, which is 3.2 times 10 raised to power 308, is not. Then let's compute x equals a plus b all over 2 and y equals a plus b minus a slash 2. As you can see, the first expression results in infinity, but the second gave the expected value. Part 2, Python via Google Colab. We repeat the same process. We set A equals 1.7 times 10 raised to power 308 and B equals 1.5 times 10 raised to power 308. Then let's compute x equals a plus b all over 2 and y equals a plus b minus a slash 2. As expected, the first expression results in infinity, but the second gave the expected value. Part 3, Excel. Here we need to be careful. Some numbers cannot be entered even if they are below 1.797 times 10 raised to power 308. That's because according to this Microsoft documentation, the maximum number you can enter is 9.999 times 10 raised to power 307. Let's enter 1.2 times 10 raised to power 308. You can see that Excel is treating it as text. The E remained the way we typed it in. But if you use 9.5 times 10 raised to power 307, you can see the E is changed to capital E and the number 9.5 becomes 9.50. So here, we set A equals 9.7 times 10 raised to power 307 and B equals 9.5 times 10 raised to power 307. Then let's compute x equals a plus b all over 2 and y equals a plus b minus a slash 2. As expected, the first expression results in hashtag name, but the second gave the expected value. Finally, C#. We repeat what we did for MATLAB and Python. We set A equals 1.7 times 10 raised to power 308 and B equals 1.5 times 10 raised to power 308. Then let's compute x equals a plus b all over 2 and y equals a plus b minus a slash 2. Let's check the console. What? Both return the expected values. That's interesting. Let's set intermediate z equals a plus b, and then compute x as z slash 2. Now you can see. So even if we had written a plus b all over 2, the C# compiler is intelligent enough to know that a plus b minus a slash 2 is a better way to carry out the operation. So here it is what is happening. Because the addition operation precedes the division, the intermediate result of the addition is not representable, overflow occurred, and that error cascades down through every other operation that comes after the addition. But in the second expression, we have performed it in a way to prevent overflow. This is why the two operations are mathematically the same, but not computationally the same.